So the second session, so the first talk is by Joaquin. Joaquin is from Facebook. He has a history of a machine learning researcher. So he was at the Max Planck Institute in Germany. And then he also worked at Microsoft in Cambridge. He worked on Gaussian processes. And he worked also on advertising system with Microsoft Bing. And now he's with Facebook, where he's actually, trying to put machine learning in the hands of every Facebook engineer and help us build better products. And he will talk about that right now.
Awesome, thank you, David. Before I get started, I want to give a huge shout out to the folks who organized BayLearn this year. And the reason I know how painful it is that back in 2013, I actually helped organize BayLearn. We hosted it at Facebook, and it was a huge amount of work. So thank you, guys. All right. Yeah, so my name is Joaquin, and I lead the Applied ML team at Facebook. And what I'm going to try to do today is I'm just going to try and walk you through a journey of a couple of lessons we've learned over the past years. In, like David said, in trying to help everybody use ML or AI. I'm actually going to use both interchangeably. I'm probably going to abuse the term AI, as we all do, and power dozens of Facebook experiences with it, right? So when you think about Facebook, right, the important thing to realize is that Facebook, as it is today, could not exist without AI. And typically, people think about newsfeed ranking, right? Because you have over like 1.3 billion people who load their newsfeed on their phones every day, and typically they have thousands of stories available to them, right? So it's essential that we rank them so that the ones at the top are the ones that we expect you to care the most about, okay? So it couldn't work without that. But that's not what I'm going to talk about today. I will not talk about feed ranking. Our mission is to bring the world closer together, and as you try to do that, you need to build dozens of other product experiences which could also not exist without AI. So I'm gonna give you a few examples of those and stuff we've learned along the way. But before that, I'm gonna go back in time, assuming the clicker works. People who know me know that I have a love-hate relation with clickers. Here we go. I remember vividly when I was a PhD student working on Gaussian processes and on Bayesian non-parametrics. Those things were popular one day, believe it or not. And I remember I was solving problems, one at a time, and typically writing custom code, very little reusability, but feeling very much like a wizard, right? I mean, I'm sure many of you in this room feel like wizards. It's an awesome feeling. And then coming to Facebook, I started to work on a very specific problem, which was to predict. I guess this is me on the clicker. All right, which was to predict clicks on ads, which is very specific, right? But then very quickly we started to have new formats of ads. We introduced video ads, and very quickly we started to show ads on other surfaces. And very quickly I also started to work on other problems. And the quick realization, right, is that you become very overwhelmed if you don't have the right tools. So the big lesson there, this was back in 2012, is that wizards don't scale, right? Now wizards don't scale unless you have the right tools, right? And then the other big learning was that focusing on the accuracy and on the quality and sophistication of the models is only one part of the equation, right? But you have other obvious things, such as how much data can you train on, what's the quality of your data, and then how quickly can you iterate. And the how quickly you can iterate to tune and experiment actually became what I became obsessed with, right? That was the most important thing was can we go to shipping new models to production every week across the company? Back from maybe in the beginning it would take several weeks to actually even complete a cycle of an offline evaluation of a new idea, right? Plus then run a small online test and so on and so forth. We thought none of that. You have to be able to ship every week. Now, how do you help wizards scale? You have to go ahead and build a factory, right? So what we did is we realized, okay, what we need to do is we need to build tools that allow people to build and execute any machine learning workflow trivially, okay? And we have a slide with a lot of colorful boxes. All right. The idea is to empower everybody to do this very, very easily, so you can move and iterate as fast as possible. Okay. The tool we built, I'm going to show you a few screenshots. Is called FBLearner. All right. So if you're a user, here you're filtering by yourself, so you only see workflows that you have executed in the past. Okay. You can browse them, and then you can go ahead and create a new one. So if you want to create a new workflow, what you can do actually is you can create an instance of a master workflow, and we have a library that you can browse of stuff that others have built. Okay. And then you can customize it. And if you want to customize it, you don't even have to write code. You can actually just you have a very nice graphical interface to modify it any way you want, right? And then when you're ready to launch it, one beautiful thing is that you don't have to worry about the physical layer at all. Okay, so FB Learner will figure out for you what parts of your workflow need to run on CPUs and what parts on GPUs, right? Like one of my favorite examples is actually a lot of the compute is spent joining data and parsing and processing data. You don't need to waste a GPU on that. You can totally do that on inexpensive CPU boxes, right? So the tool will abstract all of that for you, and you get like a bunch of nice detailed log data and so on and so forth. And then once your run is complete, what you can do is you can go ahead and you can inspect things like, okay, what are the learning curves? And actually we have like a very generic interface that allows you to export any graphs or any insights in your run, right? And one of the exciting things is that everybody in the company is on the same platform. So you can actually go ahead and browse and see what everyone else is doing, okay? Now, this can get messy very quickly because what's happening is you have a lot of people cloning existing workflows, right, and modifying them. And one of the things that I've also always been obsessed with is bookkeeping. It doesn't matter whether you do machine learning or whether you're in the pharma industry trying to build, new drugs or whatever, right? Good old bookkeeping, like keeping a very detailed track of everything you've done, every modification, is crucial, right? Both to discover stuff that works, but also to avoid duplicating efforts, right? So in the tool, what we've built is the ability to trace the lineage of any job, right? So here, this is a job that's been cloned twice. So at the bottom, you see the history of cloning. And actually, you can then go and dive deep, and you can even look at the diff between runs, right? So here, you're like, oh yeah, these three jobs are like clones of each other, and here's like the small differences between them. All right. So let me zoom out for a second. In building this platform, we followed three principles. The first one was productivity, right? If you want to ship every week, you have to allow people to move very fast. And that means two things. One, make it easy, right? So abstract away as much complexity as you can. But the other one, which is essential, is automation, right? So one observation we made is people would often waste days because they'd run their jobs in their own dev server with their own custom script. And it's happened to all of us, right? Like you misconfigure it, not badly enough that it doesn't run, it runs, but it's not what you meant to run, right? So automation, super important. The second one is reusability. You have to enable everybody across the company to look at any job anyone else has run, either for experimentation or for production, and then reuse input features, reuse the models, reuse anything. And then the third one, super important as well, right? We're not dogmatic. You can actually use any framework you want on the FB Learner platform. So we support Torch, TensorFlow, Caffe2, Scikit-learn. You can write your own binaries. It doesn't matter, right? This is a very abstract workflow execution engine for machine learning. And it's been amazing. It has worked. So right now, every ML engineer that touches production, that does ML for production, is on the same platform. And if you look at that, if you look at what fraction of all engineers at Facebook that is, it's about a quarter engineers at Facebook are actually messing with machine learning in one way or another, and they're all on the platform. And the thing that's very significant, of course, is that 70% of them at least are really non-AI experts. And if you're out there trying to hire ML experts, especially for the Bay Area, you'll realize how important it is to help wizards scale and to help other people benefit from the work of others, okay? The other thing that's really important is that this tool allowed us to build a very strong applied research community inside the company, right? And one example that illustrates this very well is about a year and a half ago, Instagram decided to switch from showing you stories in reverse chronological order to also ranking them by expected relevance, okay? So they were able to do this and ship it within a couple of weeks with only a couple of engineers. And the reason is that the newsfeed ranking workflow, both the experiments, but also the production, the training workflow, is on the same tool. So you can just go ahead and look at what are they doing, what features are they using, how are they processing them, what models are they using, right? What parameters, okay? And very importantly, you actually see who is doing what. And that's really important because you know how it is. You clone it, you try to make it run, it doesn't. So you have to go talk to the person and say, hey, what is a magic sauce? Let me know. All right, so that's a really cool property of it. Is really like bringing everybody together. And then, I mean, trivially, right? Like right now, we train on trillions of training data every day. And the problem with these slides is I have to redo them all the time because these numbers keep increasing like crazy, right? And then we train at the moment a couple of million models every month. This again is growing fast. This is 4 times more than we were doing only a year ago. Another cool aspect of the common platform is that it's very modular. So it allows you to have this stack. What we've done is that on top of it, we've built a few dedicated platforms that specialize, for example, in computer vision or in understanding text or in transcribing and recognizing speech, or even actually in training models for AI-based camera effects, okay? All on the same platform as like instances that you build on top. So I'm going to dive a little bit deeper into computer vision now for a moment. So we call our specialized vertical platform for computer vision, we call it Lumos. And it runs on billions of images every single day. We have actually, today the number is 400. This data is a bit old. We have 400 visual models deployed in production. And we have a growing training set that's now a couple of 100 million examples worth and growing fast. But now here's the thing. If what you're trying to do is make this easy for everyone in the company to build a couple of 100 computer vision models and deploy them in production, okay? And then come in and train new ones, right? You're gonna face some challenges. Let's pretend that we're in the beginning, right? What would be the first model people would train, for computer vision at Facebook? It would obviously be a model to predict whether there's a cat in an image, because that's what people care about, right, on Facebook. Now, you could go ahead and you could train a big fat ResNet, with several dozen layers, and you could train it on like a couple of 100 million data points, and it's going to take many weeks to train, okay? But that's fine. It's your first application. You're excited. No hurry, let's make it work. Find the cats. And then you have this other team that says, like, well, actually, I think birds are really important. We need to predict birds as well. All right. Well, naively, you could actually just create, a brand new network from scratch, right, and train it. It's also going to take a few weeks, right? But then when you scale this to like many tens of teams across the company and like hundreds of deployed models, the problem is that you're forcing everyone to have a huge lead time, right, for training. And the other thing is that inference is going to be expensive, right, if you have to run all of those models for every image. So what the team does is a pretty smart idea, and also quite obvious once you think about it, which is like, while train at any given time one big, massive model that predicts thousands of concepts, right, and that is trained on every single piece of data you can get your hands on, and then slice it up, okay? Slice it up and basically build tools that allow you to spawn a child model plugging in at different levels of depth. So the trade-off here is simple, right? If you plug in at the very bottom, right, you can spawn a pretty rich child. You'll get more accuracy, but you also get more compute costs, right? And conversely, if you plug more towards the outside to the output layers, you'll be able to spawn a relatively small, model, but you'll sacrifice some accuracy. But the important thing here is that you give people the power to decide where on the compute, cost versus accuracy they want to be, right? So that's what's under the hood of Lumos. Okay. So how scary is it? Like now you're a third team and you're like, hey, I actually care about predicting whether there's a person riding a horse in an image, all right? What do I do? Do I need to write, a bunch of code? You don't. We're gonna actually walk through this, right? So you create a new model and we're gonna call it, horseback riding. And so what we do here is like, all right, well, we need to add training data. You can actually, one way to add data is you can search. And this is like plain text search, right? You can search for tags or text in Instagram photos, and then you get a bunch of results back. And then what we do is we actually cluster them, and we present them to you in clusters, because that way you can batch annotate them, right? So all of those look like they contain people riding horses, except that one doesn't, and that one doesn't either. There's a third one that doesn't contain it. And then we even have like a dog there. So we're going to remove the dog. And now what we're going to do is we're going to add those images to the training set, right? So now we have a small baby training set. We can actually bootstrap the model with this. And we're going to launch a training run. Not shown here is like there's a default of where you plug into the master network, okay? So the UI allows you to look at the precision recall curves, and then there's this very nice functionality where you can do this, you can run it in shadow mode. So what you do is you actually look at public images that are being shared on Facebook right now, and then you set a threshold, right? You say, well, I want to find false positives, so let me set a high threshold for, cases where the model predicted with high confidence that someone's riding a horse. And you can again go ahead and find, this is like real data, right? This is happening now, right? You go and you find the ones that the model got wrong. You can annotate them again. This, by the way, plugs into the tools we use, for professional annotators as well, obviously. So now you have a UI that allows you to manage your training sets. So what we're going to do here is these images contain a horse, but they didn't contain someone riding them. So I'm going to annotate them as horse, but they're going to be negatives, but then maybe they'll be positives for someone else if they want to train, something to find horses. This is how I manage my training sets. And then once I'm happy with it, I'm going to go and I'm going to do an updated training run. I submit it. And once it's trained, same story. I look at the precision recall curves. I'm going to do the live preview thing one more time. I'm going to take a look at the results. And then imagine that at this stage, I look at it, I'm like, yeah, this looks good. I'm ready. So the magic happens at this moment, because this is all it takes to deploy this new model to production. And now it's going to be making predictions on every single image that is shared on Facebook. And you're done. So why do I care? I care because this is my daughter. She rides horses, and okay, there we go. And maybe I'm interested in finding images, right, where she's riding a horse. So you can sort of see that there were already a bunch of classifiers that were already running. So now we have an additional one, which is people riding on a horse. Now at the bottom you see that with low confidence, but there's still a positive prediction for clouds. But this is California, there are no clouds. So, classifiers aren't perfect, obviously. All right, so what is the most obvious application? The most obvious application is sort of I got ahead of myself. We're going to talk about it in a second. One big thing has been also to focus on performance like crazy here. Over the past couple of years, the prediction load of these models has increased by pretty much 7x, right? But through a lot of optimization and also through relying on the Café2 framework we're building for production applications inside the company, although this is open source, you can go check it out. We've been able to do this with only twice the amount of hardware, which is good, right? And then definitely like winter is coming. I mean, like the load of prediction for all the models is just increasing like crazy. So you have to be extremely mindful of performance if you want to do this at Facebook scale. All right, now to the application. So photo search is the most obvious one. If you haven't played with photo search, it's pretty easy. You kind of have your search bar at the top of Facebook, and then you have like a photos tab that I'll show you in a second. So this is me 2 years ago, and I decided to cook a paella for my birthday instead of baking a cake because it's a lot healthier. And then if I wanted to go and find that photo, this is the photos sort of search results tab that I told you about. I'd find it, although I didn't mention paella explicitly in the text, right? But that's because we have a classifier. I made sure that we have a classifier that detects paella in photos on Facebook, right? So I can find my paella photos, and that's awesome. But you can sort of see what the limitation of this is going to be, right? I mean, this is cool, but it's a bit naive, because if someone goes ahead and searches, for example, for Central Park, where we don't have a classifier that outputs Central Park, right? We have classifiers, if you look at the left part, that will look at an image and say sky, cloud, city, park, grass, foliage, skyscraper, and so on and so forth, right? You don't have Central Park. So one slightly less naive approach is to say, fine, we'll extract a bunch of concepts for the image. Now let's look at the query. In this case, we can extract the entity. The entity is Central Park. We know it's a location, right? And then you can extract knowledge or concepts out of it as well. And then you can take your favorite, similarity metric between both lists of concepts and then compute some score, and that's your relevance. Now, the challenge with this is that it's going to work sometimes, but then sometimes the intersection might be small or even empty, right? So what the search team did using using a bunch of the common tools that we all use is they said, well, why don't we train a network to actually learn to rank images directly, right? So you take a query and then you give it pairs of images and then you have humans annotate it and say, hey, which of these two images is most similar to the query that you issued? And then you directly learn to embed both the query and the images, right? And that's actually what they launched to production earlier this year. And for cool queries like, you have like Yosemite National Park or Bay2 Breakers. If you don't know Bay2 Breakers, is a crazy race in San Francisco where people dress up in all kinds of ways. These are like good examples because you have a big diversity of images which all match to the query. So recall improved dramatically through this launch. So it's a pretty cool example. All right. I don't know if you know, but a few million people in our community are either blind or severely visually impaired, right? And using Facebook sucks if you don't know what's going on in the images, right? Especially in a world where most of the content becomes images, right? So one really cool application we shipped a while back, working together with the Facebook AI research team with FAIR, was to actually train models that recognize concepts in images with enough precision, right? Basically, like, you need precision to be extremely high, and then you need to work on getting your recall high, right, on a few key concepts, right? And this is good, and then you can use like text-to-speech, and this is good. But some more recent work together with FAIR that was really cool is to actually learn actions rather than just concepts. So in this example here, which has sound, and it may or may not play, we're going to figure it out.
On stage, you're playing a musical instrument.
Okay. It just basically, this is some basic text-to-speech. It just said, the action like one person on stage and playing a musical instrument. It turns out when you ask, we have one blind person in our accessibility team that we work with a lot. He basically said that this gives a much more immersive experience than if you just said like a person, stage, guitar, because you don't know if the person's actually playing the guitar or they're just like chilling, sitting down like next to the guitar. All right. So this has been an amazing project to work on, to build Facebook for the blind. Okay, so in the same way as we have a platform for computer vision, we have a platform for text understanding, right? And it obviously is called deep text. Nothing too original here. It's fairly flexible and it supports multiple languages. We're working on multilingual embeddings as well, and it supports many objectives like text classification, recognition and linking and extraction of entities and text similarity as well, right? And under the hood, you have all of the obvious things, right? I mean, you have sequence models like RNNs or LSTMs, which have the disadvantage that they can be a little bit slow to train and they're hard to parallelize, right? So we've been also investing in actually also supporting ConvNets, and I'm going to talk more about them when I talk about translation and some work we did with FAIR on this. One thing where I actually want to pause for a second is like, it doesn't all have to be deep learning, okay? So last year, the Facebook AI research team worked on this model called FastText, and you can go to GitHub and you can look at it. And the cool thing about it is it has one hidden layer, so it's very, very fast. And what it does is it just creates like multiple n-gram embeddings of subsequences. And the magic is that in practice you get performance that's comparable to using a fancy, expensive deep net, right? So the key thing here actually is that what you offer to the customer teams across the company is you just offer them a unified interface to a wealth of models, right? If you're trying to detect, hate speech, or if you're trying to detect bullying in a very subtle, complicated setting, and you can still squeeze in a bit more accuracy by using a deep net, then you should do that, right? But there's always a trade-off. If you need to quickly stand up a model, right, and get running, start here, right? Obviously. So anyway, so FastText is pretty awesome, and I know that FAIR keeps improving it, so you guys should go check it out. And then obviously, I'm not going to talk about them, but we also have like word classification models, and we use them, to extract and link entities and all that. All right. So why should we care? I'm going to give you a cool example here. I'm going to walk you through a little journey, the journey of my friend Fazl, who's a colleague as well. All right. So Fazl loves soccer, right? And You all know that NIPS was in Barcelona last year, and it turns out that there was also a big soccer game. You know, El Clásico was in Barcelona as well at around the NIPS time, actually right before NIPS. So Fazil was super excited about it. And he was going to go and watch El Clásico, but maybe to feel a bit good, he also wanted to do something cultural or something. And so he basically posts, you know, I'm sure you've all seen posts that say, hey, I'm traveling to New York, you know, what's a good, you know, Vietnamese restaurant in New York or something like that. If you present this just as an unstructured, you know, text post, it kind of gets buried with the other posts, and it's not like really inviting. And then if you get like a bunch of suggestions in the comments, they're a little bit difficult to parse. Okay, so what the social recommendations team did is they built this simple product that detects the intent here, right? And then it extracts the key entity, which is Barcelona, and then it basically offers you the option to add a map to your post and to structure it in such a way that, you know, your friends' recommendations, when they see it like beautifully structured like that, their recommendations will also be parsed. In this case, Parc Güell, which was designed by Gaudí, is an awesome park in Barcelona. So we recognize and extract the entity here, and then we actually can place it in the map. And so your post kind of becomes alive, and you have this map that evolves with like these little points of interest sort of popping up. All right, super cool. I'll actually tell you about another crazy way people use this. Tell you about that in a second. Now we need to make sure that Fazil gets to his game, okay? So all right, so he's gonna go to Barcelona, he's gonna go to Parc Güell after that, but at this stage he doesn't have tickets to go to the game, which sucks. But luckily there's a person in California who speaks Spanish and who's gonna sell her tickets because she can't make it, right? All right, so Alisa makes a post and she says, hey, oh damn it, it's in Spanish. All right, sorry guys. Anyway, it doesn't matter. We have multilingual embeddings, no problem, right? Which means that you can actually bootstrap models quite easily. You can, basically moving our marketplace detection, intent detection models to Spanish was easy. In this case, she's selling her tickets for a Clásico for a bunch of dollars. Okay. Again, same story. This could be just this unstructured post. It gets buried in your feed, and it's not discoverable in Marketplace. What you see down there in the bottom is a little symbol for our Marketplace product, which is a place where people go and sell and buy stuff on Facebook. Okay, so we detect the intent. The Marketplace team, using the text understanding platform, basically detects the sell intent here. It parses it a little bit. It recognizes that this is the event El Clásico. It knows that it's a soccer game between Real Madrid and Barcelona, and parses the price. And then it presents this as a post, as a structured post in the Marketplace product, which allows you to contact the seller, save it for later, and so on and so forth. Anyway, Fazil didn't wait. He didn't save it for later. He immediately bought the tickets, and now he's ready to go. So Fazil is from Turkey. On his way to Barcelona, he stopped in Ankara to see his family. Okay, and then of course he was super excited. So he wrote a post, and I don't understand what it says because I don't speak Turkish. But then we're offered the translation right below it. And the translation is very strange. It talks about some giant, and I don't really understand what that is either. You kind of do, but so phrase-based, translation will sometimes give you translations that contain all the words, but it's not idiomatic, right? Like they're not like necessarily in the correct order. Earlier this summer, we migrated all of our translation models to neural nets, and what you see here is a result of migrating to neural nets, and we've seen pretty big quality improvements that I'm going to tell you about in a second. But now I know what the hell he's talking about. He's talking about the giant game, all right? So okay, so that's Fazil and the soccer game. So to give you an idea of the magnitude, if we're trying to bring the world closer together, one key fact is that 50% of our community does not speak English. It's funny, right? Because we all in this room probably use Facebook mostly in English, in other languages too, right? So we all assume that everybody speaks English. That's not true. 50% of the people don't speak English, all right? So removing language barriers is a huge deal, all right? If you're trying to bring the planet closer together. We support over 2,000 translation directions, and we serve over 4.5 billion translated posts every single day, right? Post impressions. As I was saying, before I tell you about neural nets, in terms of how many people are exposed to this, it's like 600 million people every single day see translated posts in their feed, and about like 1.3 billion every month, which is it's a huge deal, right? It's a lot of people. All right, so I was telling you about this migration. Migrating to neural nets from phrase-based statistical translation got us like an 11% increase in BLUS score, which is a way to measure similarity between sequences of text. And more importantly, you care actually about the final perceived quality. One metric we track is we actually ask professional translators to translate a subset of the post, and we use that as like the goal set. And then we look at like whether people prefer the professional translation to the machine translation one. So we actually squash the gap between machine translation and human professional translation by 25% with this launch. But then more excitingly, over the past few months, we were collaborating with FAIR, who had built, they actually had built a convnet to do translation. Like historically, you would use RNNs or LSTMs, you'd use sequence models, but FAIR actually published a paper, well, actually, it's probably more than one paper, where they share the work. And actually, I see a bunch of the people. David Granger, who introduced me, and Michael and Ronan are all here, worked on this. You should check it out. They basically allowed us to use CNNs for translation, and that's cool for two reasons. I mean, one, we get more accurate results, so that's awesome. But second, it's easier to parallelize a CNN at training time. So we actually gained quite a bit of compute efficiency by shipping this as well. So this has been awesome. All right. Now, up till now, I've been telling you about stuff that you see. All right. You see AI in action. But there's all these cases where Facebook is made better. Facebook, or like any of the other products that you guys are working outside Facebook, through using AI to keep the community safe, right? So one thing that people should not see on Facebook is hate speech and bullying, right? And this year we worked together with the Instagram team because they observed that whenever you had an increase in toxic comments or bullying in the comments of a post, people shut down and stop engaging, right? So it's like hate speech and bullying suppresses free speech, okay? So what we did is we trained text models to detect specifically hate speech and bullying, and then, again, with like huge precision demand, right? And then when we automatically remove those comments, and then we've seen engagement spike back up, which has been amazing. All right, cool. So I told you that I'd tell you how people use stuff we build in ways that we don't imagine. So remember the Barcelona post where Fazil is asking for recommendations on what to see? Earlier this year, there was yet another hurricane in Florida and in the southeast of the US. And one of the big problems is that many homes run out of water, okay? And so one of the challenges was to know, well, what supermarkets still have water, right? And it was amazing to see the community self-organize. Like people would actually use the social recommendations product to keep a live map of what supermarkets still have water available, okay? And then the person who posted it would curate it. And if they knew that some supermarket had run out, they'd delete the comment, and that way the red dot on the map would disappear, right? And we had another example from more like Home Depot type of stuff for like washers and bolts for hurricane shelters. So pretty awesome. All right, so inspired by how people can use the stuff we build, for social good. There's a team that realized that in India, that there was like almost 2,000 posts a day of people asking for blood donations, okay? So the post would look a little bit like this, or if the font is small, right? It'd be like just an unstructured piece of text where someone says they need a blood donation for a relative or a friend, and you'd have like a certain blood group and maybe contact details, maybe not, you don't know. So using the same, text understanding platform, what the team went ahead and did is they said, well, we can actually parse this, and then we can offer you the option, hey, do you actually want to create a hard link to a nicely formatted, post that is structured, where you provide, necessarily your contact info and what hospital the blood is going to, etc. And then, of course, that's not enough. Like in parallel, what the team did is they built they built the option to donate blood, right, which is equally important, right? And so to register as a blood donor, where you provide your blood group, but also like any additional medical history, contact details, and so on, and most importantly, like where you live typically and stuff, right? And then once you're registered, then the magic can happen, right? So what you can do now is you can actually send notifications to people who can donate blood if someone in your vicinity is asking for blood of the same blood group, okay? And we launched this on October 1st as part of like Blood Donor Day in India, and it was amazing. Like I don't have yet the final sort of uptake numbers, but it's been pretty awesome. All right, so I just got the 5 minutes notes. I'm gonna speed up a little bit. It's pretty cool when you can bring all of these things together. I'm going to go fast over this because you're building all of these things on the same platform. And this is a slide that is meant to show how computer vision has evolved like crazy, right? Like supported by the same platform. And again, like pose estimation is again some work that FAIR did, evolving their mask RCNN work, and it allows you to know what pose someone is in, is robust to occlusions, and it works on videos. It's really cool. All right, so I'm gonna move ahead and show you all of this in action all together. Because everything runs on the same platform, one thing you can do is you can actually recognize and tag people. You can see what actions they're doing, and you can also recognize the speech. You can transcribe it. Okay, what she said is, she said, "Hey guys, let's get some coffee." Sorry, volume was low and I was speaking over it. And we can also translate it, right? So this really allows you to have a tool that we're building to understand the anatomy of a video in great detail, okay? And also like even translate it to Spanish, for instance, so that my dad, who lives in Madrid and does not speak English, knows that I have friends that take me out for coffee. So that's cool. All right. Okay. So I'm gonna basically skip this part because I don't have time. I'll just say one thing. We're gonna release 2 big data sets. We're gonna open source them to train video models. The target is to open source them early next year. And this is a big deal because if you've tried to build tools to annotate video data sets, it's a pain. So one of them is focused on objects, actions, and scenes. And what you see here is actually the interface that the human annotators use to label those videos. I'm just gonna skip over them. And the second one is focused on generic motions. And one fun fact of this data set is that it really tries to separate the motion from the object, right? So that you don't learn, the correlation of jumping is usually performed by animals or people. Here, actually, we even have like a jumping car, right? To make sure that you just focus on the motion itself, and that's what the model learns. Okay. So anyway, to close today, what I want to share is some organizational implications that we have learned. Because what we've talked about is that wizards don't scale, and that building the factory helps scale them. But the truth is that even that is not enough. And it's not enough because technology transfer is a full contact sport. Like if you've ever been, somewhere between long-term fundamental research and close to quick iterative product development, you know the tension between the two. Now, AI and ML is a field that is evolving so fast that what's happening concurrently is that on the left side you have fundamental research, right? People are trying to solve reasoning, right? But then on the right side, I've given you a bunch of examples of products that could not exist without the models that are usable today, right? Now, if you're on the left side, you deliberately take risk, because if you're working on a 3-year horizon and you're not taking risks, then you should stop right now. On the right side, you're integrating AI into a product. You're trying to figure out how the hell to build an experience that people even understand. So risk is your mortal enemy. Now, the gap between these two is real. And you cannot expect the same person to be operating in both modes at the same time. That's crazy. That doesn't work. So this is what inspired us 2 years ago to create the AML team, is to try to bridge that gap as best as we can. Okay? And that in itself is an unsolved problem. Believe me, it's hard. But to try and do this, one thing that we do is we have a strategy that is a 3-pronged strategy. So on the one hand, we're always cherry picking, what tech seems like it's ready for product, and we sort of see that maybe in a 1 to 2 year we could integrate it into products and make it available, right? And this is like we collaborate a lot with FAIR on this. And then in the middle you know, in the middle is like the democratization piece. It's like, how can I accelerate the adoption of these technologies by everyone? And obviously, we've talked about the factory, right? We've talked about like helping people adopt things. But then third, if you remember Henry Ford's quote, right? He says that if he had asked people what they want, they would have said, I want a faster horse, right? So you have to build experiences that are exploratory and then put them in front of people. You can't ask them, you know, what do you want to do with AI? You just have to build demos and prototypes. So the accessibility project that I showed you about, Facebook for the Blind, was born out of building a demo and then you know, working with the accessibility team. All right, so I'm going to move to my last slide. There's a Harvard Business Review article that I like a lot. It's old now, but it's called Culture Eats Strategy for Breakfast. So strategy is great, but it's not enough. If tech transfer is a full contact sport, you need tools like the factory, you need a strategy, but you also need to work on the culture. All right, so the culture is expressed by values, right? So first value, you have to be a finisher. Like you know, it's very tempting when you're doing applied research to say, hey, this is semi-done, you guys take it and run with it, I'm gonna go move to the next thing, right? You can't do that. Like people won't trust you. You have to be ready to be on call with the product team who's adopting it. You have to support it, and then you have to do whatever it takes, you know, to make sure that the thing has properly shipped. The second one is if you're there in the middle, right, between long-term research and product integration, you're middleware, right? And when you're middleware, what it means is that someone else is getting the glory for the stuff that ships, right? Like you're not building a final product. So you have to be selfless. You have to be okay with someone else getting the glory. You also have to be okay with spinning off parts of your team. If you're incubating new experiences and that thing is viable and we need to build a product team out of it, you should let it go, right? And you should feel super proud about it. And then the third one is you have to be determined. That's pretty obvious. But I mean, I think that applies everywhere, right? That one is trivial. Because you try things like the Lumos computer vision platform, it didn't work the first couple of attempts, and you just have to stay focused and keep at it. So I'm probably over time. So thank you so much.
Do you have a question?
Nice talk. I don't know if I dare ask you a question about the plumbing after this nice ending, but I was wondering how you do the parallelization within workflows, and if you are able also in your FB Learner framework, and if you are able to parallelize across workflows, which may be looking at the same images or not.
Yeah, there's a lot behind that question actually, because parallelization happens at many, many layers, right? So, I mean, you can trivially parallelize like the data transformations and data preparation, so that's clear, right? Then, when you get into the guts of the workflow, it's going to be very dependent on what kind of model or algorithm you're training, right? Like, I mean, there's many algorithms are not meant to be parallelized. So what we're trying to do is we're trying to find like the right levels of abstraction to know, to basically expose to algorithm builders like units of computation that you can parallelize. And then the other thing that we do very aggressively is we try to do a lot of caching of computation if we think that it's going to be reused for other things. So yeah, and even preemption, and that's like a very active area of work that the team is working on. But I mean, it just happens at so many levels of the stack, the parallelization efforts. But the answer is yes. We cache a lot of the computation and reuse it.
One more question.
Very nice talking, thank you. And I have a question regarding the translation. You mentioned you have a 45 language and a 2K language pair. Just curious, do you have a 2K of the different model, or are you using some different technology?
Sorry, the last part, sorry, again.
So you have a 2K language pair, right?
Yeah.
So do you have an individual model for all the 2K pair, or you have some different technology to support?
There are language pairs for which we have individual language models if they're like very important language pairs, and there's others for which we use like English as a pivot language. And then like we're working, I mean, like Fair and people in the team are working also on like multilingual embeddings and other approaches.
Could we get Romain or Jeffrey to set up? Did you try your So we have time for one more question for Joaquin.
Hi, we're here.
Hey.
Quick question. As the head of the Facebook Applied Machine Learning team, how do you exercise your ethical center? How do you build a culture around determining how your tools can be used? Like, you can clearly understand so much about a user from their videos, from their posts. How do you determine what your tools can be used by all the teams of Facebook?
Yeah, no, that's a good question. The easy answer is that you know, privacy is like in the DNA of everything we do, right? And like we have like everybody gets like constant, you know, training inside the company on what data you have access to and what data you don't have access to, right? So it's already controlled at the data access layer. So I feel pretty good about that. Now, the problem of like, you know, popping the stack one level out of that and then looking at like ethics and AI, that's a pretty damn hard problem, and it's an active area of research right now, right? And there's a bunch of very cool papers that are coming out of like, you know, biased predictions by models and stuff like that, right? Which is a huge deal, right? Because they affect the user experience. So on that one, we're actually working on training material, you know, for like AI and ethics. But this is going to be like an open problem for a long time, right? And then the other areas that we're going to be investing on a lot is things like transparent and interpretable ML, which I think is going to be. I hope many people are working on that because I think it's going to be a huge area.
We can thank Joaquin again.